Okay, now we are going to see the topic scanning tunneling microscope, in short form STM. See, this is also one of the microscope. It is used to view the small size of the object. It should be in enlarged sizes, highly enlarged sizes. That is the specification of the scanning tunneling microscope. See, this is the construction diagram. In this construction diagram itself, we can see that sample. Above that sample, you have one small tip is there. That tip should be controlled by the piezoelectric voltage controller, and finally it is given to the scanning unit. See, this STM is working under the principle of tunneling effect. See, when the tip is moving on the surface of the sample, in between of that electrode and sample, there will be a tunneling current is produced. That tunneling current is weak, so that should be amplified by the amplifier. After amplification, it is fed to the controlled unit. The tip is nearer to the material, the difference in potential is applied between them. This difference, the electrons are moved through the empty space and created between them. Such method is called as the quantum tunneling. Finally, the result of tunnel current is formed. If the tip is moved close to the surface, the tunneling current is increases. If it is away from the surface, the tunneling current is decreases. By changing of these, we can calculate or we can view the 3D images in the system. This is the principle of our STM. Working. The voltage is applied and the tip brought to the sample. When the voltage is applied, the tip is bring into the sample. The separation between of the sample and tip should be 0.4 to 0.7 nanometer. So here the voltage bias cause the electrons to tunnel between the tip and sample and also create a current. When the bias and the position with respect to the sample is varied, the corresponding current will be measured. If the tip is moved across the sample, the changes in surface of the height and density of the states will causes the changes in current. So these changes are make a map and form a images. There are two modes of operation should be occur in the STM. Already in AFM we have seen that is there is three types of modes. Here it is two type of mode. One is constant height mode. The second one is constant current mode. The name itself we can understand. Constant height mode. Constant height in the sense, see the tip, the end of the tip and surface of the sample height should be constant, but there will be the changes in voltage. Voltage and height both are held at constant while the current changes, and it is also the fast method. The second one is constant current mode. Here current is constant but the height is not constant. So voltage and height are both varies, but while current is constant. It is consuming method. This is about STM. Advantages. STMs are flexible and it is used in vacuum, air or any gases, and it is used to like a properties of roughness and defects and molecular size also can measure. By using of this method, we can find out the resolution should be 0.1 nanometer to 0.01 nanometers resolution. So this is highly resolution image. Even though this method having some disadvantages, that is it is very expensive and it is cannot use all the people, it can use only the trained people. Those who are well known about the instrument, they can use. And applications, it is used to move the atoms individually and generate the high resolution image, and it is used to enhance the etching rates in various gases, and it is used to study the nanostructure down to atomic level.